Welcome to a screencast on unit circle terminology. Previously, we explored the idea of a point traversing around a circle to create a circular function. In this video, we're going to look at a special circle called the unit circle. The unit circle is called the unit circle because it has a radius of 1. And there are a couple things to recognize about the unit circle. First, we know that the circumference of any circle is 2 pi r. And since the radius is 1, we know that in the unit circle, the circumference will be 2 pi. So in other words, if a point were to travel all the way around this circle, the point would travel a total distance of 2 pi. Another thing we can recognize about this circle is that for any point that lies on the circle, xy, we can think about drawing a right triangle where one of the legs of that triangle is x, and another of the legs of that triangle is y. So from the origin, we're traveling a distance to the right x and up y to get to this point xy. Now that we've labeled the legs of this right triangle, we can use the Pythagorean theorem and recognize that x squared plus y squared equals 1 on the unit circle. So these two things will be important for us to apply to the unit circle quite frequently, that the circumference is 2 pi and that any point in the circle satisfies the equation x squared plus y squared equals 1. There is also some terminology that we want to be aware of when talking about the unit circle. An angle is in standard position if its vertex is located at the origin and one ray is on the positive x-axis. So this angle is in standard position. Or we could say that this angle is also in standard position, or maybe even over here in the third quadrant, this angle is also in standard position. For future reference, let's call this first angle alpha, this second angle beta, and this third angle theta. All of these angles are in standard position because the vertex is at the origin and one ray is on the positive x-axis. We call the ray on the positive x-axis the initial side, and the other ray is called the terminal side. So, for example, in angle theta, this side at the end is the terminal side. A central angle is an angle whose endpoints are located on a circle's circumference and the vertex is located at the circle's center. So in fact, angle alpha is a central angle because the vertex is at the origin and we have two other endpoints that are on the circle's circumference. And angle beta was also a central angle because again, the vertex is at the origin and the endpoints are on the unit circle. Lastly, a central angle in a circle will determine an arc. An arc can be thought of as a portion of the circle's circumference. So the central angle alpha determines this arc, the central angle beta determines this arc, and the central angle theta determines this arc. The arc goes from the initial side to the terminal side, as you can see, and it measures the length of a portion of the circle's circumference. In the next video, we will look at central angles and their relationship to the length of an arc on the unit circle.